This is the lecture over algorithms and their representation. In this lecture, we're going to be talking about what an algorithm is and how to represent these algorithms. And we're going to show two generalized forms. The first one is representing an algorithm in pseudocode, and the second one is using flowcharts. And then we're going to show how the pseudocode and the flowcharts can actually relate to each other. So, what is an algorithm? An algorithm is a series of instructions to accomplish a specific task. Simple tasks have simple algorithms. That makes sense, okay? The more complicated the task is, the more steps you're going to have, and maybe the more sophisticated structures you're going to have in the algorithm. Complex tasks have more involved algorithms, which can have nested algorithms. Now, what does nesting mean? Okay, what that means is you can have a less complicated algorithm nested inside of a more complicated algorithm, and this less complicated one is called as almost a function or a subroutine of the first one. You will see as we go on through the semester examples of this. Again, the two most used methods for representation of an algorithm is pseudocode and flowcharts. Now, the types of actions that are portrayed in algorithms are the simplest form is a simple statement. This is one specific action on a single line. These are executed in sequential order, and they can be simple expressions or function calls or data I/O. I/O stands for input and output, and it means you're either reading or writing data. Then you can have some more complex structures, and that is the decision structure, which changes the program flow. And then you can have repeat structures, which also change the program flow. We're going to be looking how each one of these are represented in pseudocode and flowcharts. Now, pseudocode, it's a simple tool that describes an algorithm using informal language. By informal, and the emphasis here is it's informal, it's a language that's in the vernacular of those involved with the discussion and design of the algorithm. And because it's informal, it puts the focus on the logic of the process and not so much on the computer science terms and the specialized words for a specific language. It allows all who are involved in the design of the algorithm to participate in the discussion on the algorithm. And this means specialized words used in specific programming languages should be avoided. Do not use coding statements in pseudocode. Remember, it should be expressed in the common language of those people involved in the design of the algorithm, or even those that are going to be using the output of the algorithm. Now, some general guidelines for when using pseudocode are as follows. Only write one statement per line, okay? And those statements, unless otherwise indicated, are carried out sequentially, one after the other. You should number the lines, and this is for reference. For instance, you can both you could be discussing it with someone on the phone, okay? You both have the algorithm in front of you, and you can say, but here in line 10, I want to change the flow of the program here, and the guy can look on his sheet, the guy or the girl can look on the sheet they have, and they know exactly which line you are talking about because they can see what line 10 is on their sheet. Okay, so you should number the lines for reference. And you should always end multi-line structure. Multi-line structures generally occur when you're making decisions or repeat structures. When more than one line of code is involved in a structure, you should actually say specifically that it is ending after the last line involved. And you'll see an example of this later on in this lecture. And we want to keep the statements programming language independent. Okay, we mentioned it on the previous slide. We're mentioning it here because you have got to adhere to this. Do not use programming code. Once you get familiar with C, you're going to be tempted to use the syntax of C just because it's so simple and concise. But it can be confusing at times. So, and it might not really portray what is actually going on in the situation. So please keep the statements programming language independent. And again, why should this be code independent? It is because not everybody who's going to be discussing the algorithm is a programmer or might not even know how to program anything, any language, okay? And you should be using, I would say, a language that's the lowest common denominator between all involved, and that generally means avoiding program language structure in your statements. Now we're going to introduce a simple problem to demonstrate the use of pseudocode. And this problem is we're going to be exploring new lodgings. I've got tired of the apartment I'm living in, and I want something new. Now, in order to do that, I need to know what I have been spending on housing over the last couple of years. Okay? I have all that data, all my finances in a file. Okay? Unfortunately, the file contains all my expenses, including utilities, gassing, clothing, as well as housing. Okay? What I have to do is somehow pull out just the housing information and perform the needed computations in order to get the average for the year. Now, how can I do that? Okay? Let's make a first pass with pseudocode. Okay? And we're going to first of all name the algorithm, and we're calling this algorithm averaging housing expense. Okay? And we're giving it version 0, and you'll see why that's actually version 0. We're going to put line number 1, read a transaction from each line of the text file. Number 2, if the category of the transaction is housing, add the amount to the total expense for housing. Number 3, after all lines are read, the monthly average for housing is the total expense for housing divided by 12. And then finally, print the monthly average expense for housing. Okay? This isn't quite correct. And the reason is there is no indication in the way this pseudocode has been written that lines 1 and 2 have to be done for each line of the text file together. Okay? These must be performed together. So how would we actually do that? Well, before we go on and show you how that can be done, we need to introduce 2 special control statements that alter the sequential order. The first one is called a conditional. This is where the structure allows a block of code, allows a block of instructions to be executed under some conditions, but not executed under other conditions. This is also referred to as a selection, okay? In other words, the program is making a decision, okay? This is how decisions are actually shown in computer algorithms. The next control statement is for repetition. This allows a block of instructions to be formed more than once. And generally, a lot of times, what the block of instructions that need to be repeated contain multiple lines, okay? And this is referred to as loops, okay? And now adding those control statements to our algorithm, we can see that we have introduced the word repeat, okay? So here, this is where we're entering the loop. And it says repeat as long as there are unread lines, do the following. And since there's multiple lines inside the loop, we are ending the repeat. That's what we meant by make sure we end multiple line structures. Okay? This structure has 4 lines, and since that's more than one, we have to explicitly end it. Say where the loop ends. Okay? So, we can see that the loop is lines 1 through 5. Okay? What's in the orange rectangle here is those statements which are repeated through each iteration of the loop. And what we also have is a conditional inside this loop. And then what is shown in the green is only executed if the category of the transaction is housing. That's the test. If the category of the transaction is housing, then the amount is added to the total. This is how a conditional is portrayed in pseudocode. And then once we have read all the lines, and otherwise we're going around and around, reading transaction and testing if it's housing, and if it is, adding it to the total. As we go around and around, eventually we're going to run out of lines in the file, and this condition will return false. There are no more unread lines. So then it's going to drop to line 5, it's going to end the repeat, and then it's going to compute the average as the total divided by 12 and print out the housing average. Okay? That was our simple problem represented in pseudocode. Now we're going to see how that can also be represented in a flowchart. Okay? And actually what you see here is the problem represented in Flowchart. But before we get into that, we're actually going to get into the specifics of what a flowchart is. And in general, flowcharts are simply a graphic method for showing the flow of control. And this can be sequential, repetition, or conditional statements. They lend themselves quite nicely to primitive media, which means back of the envelope or on a napkin. And there's no strict rules about how to construct a flowchart, but there are conventions. In fact, there's many conventions, and these conventions vary quite a bit from field of use, from field to field. We will be going over in the next couple of slides the conventions that you will be expected to adhere to in this class. The first item of a flowchart that we are going to go over are simply flow lines, okay? And those are actually arrows, okay? The flow lines are what connect the other elements of the flowchart with the process flow direction indicated by the arrowhead, okay? Double-headed arrows are not permitted, okay? Like in this situation where you've got an arrow at the end of each line, this is not allowed because it indicates arbitrary control or random control. And each one of these lines, you see the arrowhead is only at one end of the flow line. Okay? Now, when two flow lines come together, a junction is formed. And these are permissible as long as there's only one arrow coming out of the junction. You can have multiple arrows going in, okay? But only one out arrow is allowed. More than one out arrow again depicts arbitrary control and is not allowed in a representation of a rigorous solution. Now, the sequential elements of a flowchart are the start of a flow line, which you will see as an oval and the word start in it, and then it has a single out arrow. No in arrow, but a single out arrow, okay? The end of the, okay, and it can have multiple. You can have more than one start at in a chart. It just depends on what state the program's in when the algorithm starts. Okay? Now the end of line of control is depicted by an oval with the word end on it, and these will have multiple in arrows and of course no out arrows. Now a block statement, okay, is simply a block that has a single statement inside, something to do, okay? It could say add value to sum, divide by 10, whatever. Each block is a statement or a single action that has to be performed. And these typically have only one in arrow, but they can have multiple, okay? But only one outline, okay? You'll see that as a common thread, only one outline, okay? And this again describes a single step in the process. Now we're going to talk about how decisions are made, and then we'll see the two structures that actually use decisions. Okay, the shape for a decision is a diamond, and this implies the answer to a binary question. Now, what do I mean by binary? Okay, lots of questions aren't binary. Well, a binary question is one that has two possible options: yes, no, true, false, positive, negative, or selecting one way or the other. There's only two options that are given as allowed answers to the question. Okay? Generally, again, only one in arrow, although you can have multiple in arrows, and you can have two out arrows. Okay, this is the only structure where you're allowed to have two out arrows. And you have one for each side of the binary question. If the answer is yes, true, or positive, you go out one way. If it's no, false, or negative, you go out the other way. Okay? This implies a strict, rigorous control. Only two choices. You make one. Whatever choice is made is dependent on the condition that the program is in at that point, or the question, the answer to the question that is asked here. Okay, and it has the change of the program flow based on the answer of that question. Okay. Now, this decision structure is used in our conditional structure of the algorithm, the if, okay? And we can see that this implies either something is done or not, okay? If the condition is true, meaning we're coming down here on the flow, we come down, we hit the diamond, and a question is asked, or a condition is probed, or a signal is measured. Okay, the signal is either negative or positive. Okay, the condition is either true or false, or the answer is either yes or no. Okay? If the condition is true, you go and you do something. Okay, and then you continue on. If, however, or otherwise, if the condition is false, you go out this way and you actually skip that do something, and then you join back to the program line and you continue on. So you can see the if conditional skips either a block of code, it either skips it or it executes it. Those are the two choices. And this is how it is shown on the flowchart. If, on the other hand, you say you want to do one thing or another thing, meaning you're not skipping something, you're just changing the course of action here, okay? You, again, use the decision, you apply the test, and if it's false, or if it's true, you do one thing, or if it's false, you do something else. And you can see after you've done either one of those actions, you then combine again and carry on with the program. Okay, so this is how you either do the one thing or the other choice is portrayed on the flowchart. Now the next structural or algorithm structure we're going to look at is the repeat or the repetition, the loop. Okay, how is that portrayed? Again, you can see we are using the diamond shape, and the program flow at this point is you're coming from the top and you're heading down, and the first thing you're hitting is this condition test. Okay, is the condition true or false? Is the answer yes or no? Is the signal positive or negative? You're hitting this condition test. Okay, and this test is what determines if the loop is performed or not. If it's true, you go ahead and perform the loop task, and then either in the performing of the task or after you perform the task, you have to update the loop condition. If this step isn't in there, then you're never going to change the condition of the looping test here, and you'll get yourself locked into an infinite loop. Okay? So if the condition here is true, you perform the loop task, you update the condition, and then you come back and you test the loop condition again. Okay? The loop test is performed, and you head back to the test step. If the loop condition is false, you simply exit the loop and continue on with the program. Okay? Because the condition is tested before the loop is performed, okay, the loop task might never be performed. Almost had a double negative in there. Okay? And this type of loop is referred to as a pre-test loop, meaning the flow of the program comes and you hit the test condition before you hit the loop task. Now, what we're going to do is we're going to look at both the pseudocode and the flowchart for our simple problem. And you can see the first thing that it's happening after the begin, we hit the repeat in the pseudocode, and while there are unread lines, here we're coming to our diamond, while there are unread lines. Okay? We read the next transaction, and if the category is housing, so here it was true, we read the next transaction and we hit our conditional. If the category is housing, we add the amount to the total. You can see here we're adding the amount to total, and this loop will be repeated until there are no more lines to read. And in some cases, it's not going to be housing transaction, and so you're just skipping the step where you're going to add the total amount. Okay? But as soon as there's no more lines to be read, this will come up as false because there's no more lines to be read, and then you head out this way where you are going to compute the average and then finally print out the output. And then you go to your end control. So in this slide, you can see the pseudocode with the corresponding flowchart. Both of these clearly and explicitly show the control of the very simple solution we have for this simple problem. Okay? In class on Friday, we're going to be working an additional problem that we have written down here. Professor Edison would like you to write a program that calculates the percent of exam scores in the 5 intervals 100 to 90, 89 to 80, 79 to 70, 69 to 60, and then less than 60. He has the data for multiple exams in a file in which each line has a student ID, an exam number, and an exam score. Okay? He has asked you to provide a simple program for him to use to actually calculate the percent of exam scores in these 5 intervals. So what I'd like for you to do is to just read this problem again, think about it, and come to class prepared to, number 1, go through the steps of investigating the problem and the solution like we discussed in Wednesday's lecture. And then we're actually going to be looking at this problem in both pseudocode format and flowchart format. We'll probably look at a few simpler problems to start out with and then end up breaking into groups and discussing this one. Okay? That's the end of this lecture, and we will see you in class on Friday.